Alright guys, so today we're going to talk about operating functions. So I'm going to teach you how to combine functions types and with arithmetic operations in contextual situations. And we're going to write a function that describes a relationship between two quantities. So what you're going to learn from me or from this video is how to create new functions from given functions from tables, and how to create new functions from given functions from graphs, and how to evaluate combined functions. So function notation. So function notation, you've probably seen it several times. It looks like this. All of these are examples, and you can use any letter you want to, but this is called function notation. And how you read this, you say f of x. So you read this f of x. This is g of x, and this is c of x. Okay, so what does f of x and the x mean? So over the f of x is the same thing as saying y. That's what you're used to. And the x that's in parentheses here is the same thing as the regular x that you're used to. So the whole thing itself is the same thing as saying y. So g of x is the same thing as saying y. C of x is the same thing as saying y. Okay, the x is called the input value, and the f of x is called the output value. All right. So here, if you're asked to evaluate a function, so in other words, if you're asked to do f of 2 or c of 2 or g of 2, what this is telling you to do is to substitute in this right here. They gave you the value of x. So what this is saying, find the value of y, because this is called y. F of x is the same thing as y. Found the value of y when x, they gave you x, is equal to 2. And that's what all of these are saying. Find the value of y when x is equal to 2. Find the value of y when x is equal to 2. And it doesn't have to always be 2. It can be 3, 4. They're going to just give you what the value of x is, and you have to find the y. Or another way of saying this, find the value of the output, which y is called an output, for when the input is equal to 2. So find the value of the output when the input is equal to 2. And these numbers, the input values change. So if the input value changes, so will the output value. All right, so let's go ahead and talk about how to do this. So this right here tells us to graph the tables, and I should have had a grid already ready. Okay, so it says to graph the tables, and here's what I'm going to do. I'm going to go and use GeoGebra. So you can tap on GeoGebra on your PDF, and it'll take you straight to it. But I'm going to click on GeoGebra geometry here so that I can get me a grid going. I'm going to push this wheel right here, and I'm going to push show axis, and then I'm going to push this wheel and go show and then major grid. So I am going to graph those points from this table onto GeoGebra. So I'm going to do the first thing, -2, 0. So I'm going to click on where it says point. That's -2, 0. The next point is 1 and 5. So here is 1 and 5. Oh, wait a minute. If you need to move a point around, then you just push the move button and move it where it needs to go. The next point is 4 and 6. If you need to move your grid like what I'm having to do so I can see it, I just push the move button and then I drag it down. And I'm going to push on point again. So I'm going to do 1 and 6. So I got 1 and 5. I'm sorry, 4 and 6. Okay. And then I'm going to do 6 and 8. So that's this point right here. I'm going to just assume that this is a linear function, or where these are connected by lines and not curves. So I'm just going to go and connect the dots like this. Since it didn't give me a picture, I'm just going to do that. And then I'm going to go and graph the other table, which is this table. This is the f of x table, and this is the g of x table. And then here, I'm going to go here, and I'm going to graph that table. So the first point is -6 and 5. So this is -6 and 5 right here. And then this is -2 and 8 is my next point. So -1, -2, and 8 is my next point. And then 3 and 4 is my next point. And then 6 and 2 is the next point. So 6 and 2, there we go. And then I'm just going to go and connect these as if they were lines instead. Since it didn't show me a graph, I'm just going to assume those are lines that connect the dots. All right, now on your paper, I'm a little limited right now. Well, hold on. On your paper, here's what I would do. Well, no, I wouldn't. Yeah, on your paper, here's what I would do. I'm going to go down here and look for where I can type it. And I'm going to go ahead and name these functions and put it beside it so that I'm not confused. So one function is called f of x. That's this function. And I get f of x because that was the table. It had f of x in it when I got ready to graph. So I'm just going to call that out, the outputs of that function f of x. And then my other function is called g of x. So I'm going to go type in g of x for that function. And where did I get that from? Because right here, the y value was called g of x. Okay, so now I need to follow some instructions from that graph. And I'm going to take a picture of this so I can stay on my page and just look at the graph instead. So give me a second. Let me take a picture and I'm going to insert it in. All right, so here is my graph. So I followed that instruction and I have my graph right here. And then from here, I'm going to do what it said. And now it's telling you graph x plus f plus g of x. So, but first, I need to create another table so that I can find what f plus g of x would actually be. So it's telling me to add these two functions together. It's telling me to add these two functions together. So here I would look at adding -2. It says we're going to graph Okay, so now that we have our graph, we need to add the two functions together and graph. So if we look, looks like the only number that these two functions have in common according to our table is 6. So we're going to have to use our graph to help us solve this question, or to graph the addition of these two functions. So I'm going to make this bigger so we can use this information. So we're going to have to go and create another table. And we're going to call this table f plus g of x. All right. And then we're going to start, and we're going to do this simple. We're going to start our table at I was going to use a trick in college. No, I'll tell you how to use this table instead. And we'll do about 4. We'll do the same many that's on the table. Okay, so what we'll do is we'll call this my x value. And f plus g of x, we're going to name it a new function, and we're going to call it c of x, or you can call it whatever you want to. So we're going to go here, and we're going to say where we're going to say at -2, f of x is 0. The output is 0. And I'm going to create another one, and I'm going to say x and then g of x when x is -2 for g, we get the output to be 8. All right. And then here, I'm going to look at another spot where they both intersect at. That's at 0. So they both have an output at when x is 0. So 0 and 0, one graph meets here and the other one is here. So when f of x is, when the x is 0 for f of x, you get about 3.5. And then when g of x is 0, we get about 6.5. That's right here. That's this spot up here for the g of x. And then the black is for the f of x. All right. And then here I'm going to choose one more point. I'm going to go ahead and choose this one out here, which is 6. So when f of x is 6, we get 2. And when g of x is 6, we get 8. When x is 6, we get out 8. Okay. So now what this is telling us to do, now that we found like values, we're to add these two together. So my c of x, which is what we said we're going to call this function when we add them together. So c of x would be when we just rename it when we're combining. So we're saying the combine function there. X c of x. All right, so if we go down, so now we just add. So when we get -2 and we add these two functions together, 0 plus 8 is 8. And then here 3.5 plus 6.5, 6, 7, 8, 9, that would be 10. So when we get to 0, we get 10. And then when we get to 6, we add these two together, we get 10 as well. Okay, and that's just going to give us a piece of the function. So now we can go and graph this. I'm going to go to GeoGebra, and I'm going to go and graph this. And I'm going to tell I'm going to tell GeoGebra to clear. Don't save that, and I'm going to just get my wheel up again. And then I'm going to graph my new table down here. So -2 and 8. So -2 and 8. So I need to move this down so I can see 8. -2 and 8. And you could have extended this table for as long as you wanted to. And then 0 and 10. 0 and 10. And then 6 and 10. So 6 and 10. And then I'm going to assume that these are lines, which is called piecewise functions when you have lines pieced together like this. This is called a piecewise function. All right, so A, B, and C is here together. And what ends up happening is we're going to go down here and write on this function text. And this was my, you know what, I could have put this on the grid with the other one as well. I'm tripping. You could have put this on the same grid, guys. F, maybe I'll do it in the next one. F, F plus G of X. And there you go. You could have put this on the same grid. And then if you want to keep going to get more of the graph, you just keep that table going. And then we're done with the graphing part. So I have, let me take a picture of this. I'm going to push the zoom here so I can see it a little better. And then I'm going to graph this picture. You can do this on paper, guys, and you can put it all on the same grid if you want to. You could have put it on the grid with this. And you know what? I could have graphed it on the grid with this. As a matter of fact, I am, so you can see it. So here, you get -2 and 8. So that's up here. And I'm going to call that, I'm just going to call it K. And then we get 0 and 10, which is out here somewhere. So I'm just going to show it out there anyway. And I'm going to call it K, J, and then 6 and 10, which is somewhere out here. I don't have enough space. And I'm going to call that L. And then I'm going to go and connect the dots. And I'm going to do it in red so you can see all three on the grid together. And then this is F plus G of X. And there you go. And you can keep this graph going by continuing to collect data points from the other graph. Well, you have to get kind of some in the middle where they both have points at. Okay? And let me see what the next part of the question is, because I know there's something else that needs to be done. And can I move this together? Yeah, I'm just going to slide all this down so that we can answer the questions now. Now it says find F plus G of -2. So if I go here, F plus G of -2 is going to be equal, when I go here, and let me help you write that down. So you go to the plus function, which is in red, and it's telling you that the X, tell me what the Y is when X is -2. That's what we're looking for. So I'm going to go to -2, and the Y value is 8. So the answer to that question is equal to 8. Okay? Now it says, give me the F plus G, where 6. So it's still telling you to use the red function. And here, the X is equal to 6. Now, what would the Y value be? So here, I'm going to go to Y, and we said that was at about 10. So we're done. Or you could have used your table as well. Let me go down here and show you. You could have used your table since it was on there, -2 and 8 and 6 and 10. We got lucky that time it was on the table, but for sometimes they're not on the table, and you have to use the graph. Okay, let me see if I have another one. All right, so now we're going to do this one where it says use the graph to graph G minus X, G minus F of X. So we're going to subtract these two functions. So I'm going to show you how to do it. So we're going to get a table. We're going to make our table. And these functions are called G of X. And the other one is called f of x. That's what the second one is called. That's this one. And I got it just from what the y-axis was named. All right, so it looks like these both have values at, and I'm going to do the lowest value first. They seem to have a y value both at 1. So I'm going to use 1 for this one. So 1, looks like if I go up here, it looks like it's at about 3. And then if I do 1 for my F table, then it looks like it's at about 2. That point's right there. And this point is right there. So it looks like they both have a value at 3. So if I do 3 for both graphs, then I do 3, and there's going to be -1 for g of x. And then if I do 3 for f of x, I get 6. And then I'm going to go here. Looks like we're at 5. They both have a value at 5. So 5, I get 3. And over here, 5, we get 2. Okay? So now this is telling me to subtract these two tables. So I need to subtract F out of G. So I'm going to go to the G table, and I'm going to change this color just because the red is bothering my eyes. So when I go to do my subtraction, I'm going to call this F, and this is going to be G minus, we can rename that, and we can call it C. C of x, or you can call it G of x, G minus x of x, G minus f of x. You can call it that if you want to. I'm just going to call it C, so I'm not writing all those letters. That's what I'm going to do. C of x. All right, so at 1, when I do 3 minus 2, I should get out 1. And then when I go to 3, I get -1 minus 6. So -1 plus 6 is -7. And then when I go to 5, I should get 5. I should get 3 minus 2, which is going to be 1. And I want to test something because I want to see if this graph is going to actually be a parabola again. So I'm going to go and look for some other values on here too to see if this is going to be a parabola again. So when I get ready to graph it, I get a parabola out. So I'm going to stick 2 on my table, and I'm just testing. So 2, and I'm going to put, I get 0 here. And then if I put 2 on this side, I'm going to get out 5. So if I put in the number 2, then 0 minus 5 is going to be -5. And then I'm going to go to a number that's below 1 on both of these graphs so I can test something out. Because it looks like I'm going to get a parabola back because I see 1 is starting to repeat here. So we're going to go ahead and make that assumption that we're going to get a parabola out. And let me see something. If I test below 1, I'm going to go ahead and test 0. So if I get 0 for both graphs, if I do 0 here, and I'm going to expect that to be something close to -5. If I get 0 for this graph, it looks like if I keep this pattern going, I go up 1, over 2, up 1, up 1, here, 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 and it gets smaller. It looks like I may drag out at about 7. And then here, I'm going to go to 0 here. And it looks like I get -3. Is it -3? Yeah, I get about -3. And then here I must be a little more than -7. That must is going to hit at 8. I'm not correct. This one hits at 8 at the top. Nice. So here, if I do 0 on the graph, and 0 would go up here. So let me go ahead and slide it into this table so I can show you what I was looking for. And you don't have to do this to test this. I'm just doing it to show you how to test it. 0, 1, and 1. And I'm going to add a line here. And so if I put 0, it looks like 8 plus. So what I was trying to test looks like it's not going to quite work. So this is not going to be a parabola. It looked like it was going to be a parabola based on this table. But it looks like it's going to be 8 plus -3, because this down here turns out to be -3, which is going to be 8 plus -3 is going to be 11. So I thought I was heading in a parabolic direction, but I'm not. So I'm just going to go ahead and graph this and assume that it turned out to be a linear function. So I am going to go to decimals. I mean, not decimals, but GeoGebra, and I'm going to graph this, and I'm going to assume that it's just going to be a line. Okay? So I'm going to go here and clear this, that this is just going to turn out pieces. All right, so I'm going to do 0 and 11. And you didn't have to do the extra steps that I did in there. And I did that so that I could try to see something. 0 and 11, because I was trying to figure out whether this is going to be a parabola or not, our new picture. And then we get 1 and 1. And then we get 3 and -7. 3, 3 and -7. And then we get 5 and 1. See, that made me think it was going to be a parabola. And then we get 2 and -5. So 2 and -5, which is about right here. So I don't know. It looks like it might end up being a parabola. So we're going to just go ahead and take the shape and connect the dot and assume it may turn out to be a parabola. I was trying to test it, but we'll go ahead and draw a curve on it. So you go down here. You can go down GeoGebra and then click on where it says freehand shape, and then just connect the dots, baby. And we're just going to assume this turns out to be some type of parabola. Okay? So from there, then we're going to use this information. And I don't like the way it drew that. Hold on. Let me undo that. I'm going to do it like this. Oops, redo my points. I want more of the vertex to be right here. Let me just delete that out. So I'm gonna go freehand and I'm gonna try to draw it neater. Let's see if he catches it now. It still ain't give you no at right. So I'm just gonna go to pen and I'm gonna draw it like this. Okay, so I'm gonna assume my shape looks like that, where my vertex seems like it might be right there. And this is a little higher. And you don't have to make it perfect, guys. This is just me being me. Okay? You don't have to make it perfect. I was trying to make the center look like it's supposed to be in the vertex. So this probably should have been a little more skintier. My point needs to be moved over some more. So it doesn't look like it's, was that 2? It was 2 and -5. So 2 and -5 is about right here. So something like that. Okay, anywho, I'm tripping. So we'll have it look like that. And we'll draw the graph. I'm gonna go take this graph and put it on my page because that's what it asked me to do. Control copy. Control V. And then I'm going to make this smaller and we'll go from there. Okay, so that's the graph from the subtraction problem. Let me drag this up and I'll stick it right here. Alright, so that's the graph from the subtraction problem. And now we're going to use this to kind of help us do what we need to do. So it says we need to do, from this graph, we need to find where is the answer at 3. So here, x equals 3. So what is y from this graph right here? This is g of f of x, or what we called it, c of x. So we need to go to about 3 on here and see where it falls at, and it looks like it's at -7. So we write -7. 3 is about right here. And I'm going to do it in yellow. So if I go 3, it looks like I'm at about -7. Oh, no wonder I got that point wrong. It's supposed to be way up here. My bad, y'all. On E, I don't know, what was I thinking? 2 and -5 should have been right here. Forgive me. I'm struggling right now. All right, and then for 4, it asked me to find the value at 4, and it looks like, according to our question, if x equals 4, it looks like we get out an answer at y equals -4. So that would have turned out to be some type of parabola in there. And I'm sorry about that graph. That point I messed up. Okay, so let's keep going. I think that's the last one. And then we finish. And I know this video is a little longer because I tried to be as detailed as possible to show you guys how to do it and use GeoGebra at the same time. So work with it, and I'll see you in class. Bye.